I see, I remember you. If you remember me.
Hello friends, welcome to 7-minute study. In this video I am going to talk about a language processing system, how it basically works. In the previous video I have talked about what are language processors, namely compilers and interpreters, how they work. In this video I am going to talk about a language processing system. In addition to a compiler, sometimes we would need other programs which are required to create an executable target program. Okay, we know, right, a target program is needed for us to process some of our inputs to generate the desired outputs, right? So we would need, in addition to the compilers, some other what do we say, programs which are required to generate a target machine code or a target program. So a source program is first divided into separate modules which are stored in different files at various locations in our memory. So we need a preprocessor program or a macros. We also know, also call the preprocessor program macros. Let's say hash include and hash define are example macros programs which are predefined. In C we use hash include stdio.h to include our standard input and output header files, where we have the header files having the source programs headers stored. So these are the general preprocessors. These are known as preprocessors because before getting a target machine code which processes our input, we need these macros to be loaded, which are written by default into our systems. uh, which mean we need to have the compiler loaded beforehand. That is, if we are performing on C, we need the C required compiler on our system. So basically we use IDs such as code blocks or Dave, C++, etc. That's the preprocessor, and then this preprocessor is used to get to link all the modules together and get a modified source program. This modified source program is then fed into a compiler. This compiler generates a target assembly program. As an assembly language program is easier to be generated or easier to be written, and it is easier to debug, that is to identify and remove errors. An assembly program is basically written using symbols add, sub, etc., or increment or decrement, etc. These are known as the instructions, assembly language instructions, and this assembly language program is then fed into the assembler program. Okay, this assembler predefined program then generates a relocatable machine code, which as its output. Large programs are often compiled in pieces, right? Because we can't have only one piece or two pieces. In case of large programs, we'd have to have large number of modules. So all the source program would be divided into number of pieces or number of modules, and then we get till the target assembly program. And after the assembly program, we get the relocatable machine code. And as large programs will have are often compiled in pieces, the relocatable machine code might have to be linked to other relocatable object files or library files into the code that which are actually used to generate the target machine code. Okay, so what's happening here? We are using the linker to solve the external memory addresses problem, because we have different parts of the program written or loaded at different places in our memory. So the linker links all these parts together and generates all these relocatable object codes combination. So these object files, after being relocatable object files and library files, after being combined, we need a loader which loads these into which loads these from our main memory and puts these into execution. After they have been executed or processed, we get the required target machine code. To this required target machine code, we give our inputs. In some cases where we had to give some inputs to the program, or directly we get the output, and the desired task of the user from the machine has or will be completed. Thank you for watching the video. If you have any queries or if you have any suggestions, please mention in the comment section or drop an email to my email ID, which will be in the comment section. Thank you.